Hello everyone, I welcome you all to today's session wherein we are going to discuss a very interesting, very popular topic, geometry. This is also important from point of view of your competitive exams like CAT. So today geometry is a vast topic, right? It would be taking several such videos, many such videos. But what I try to do here is I have tried to put my focus more on the solving part rather than on the concepts part. However, the video is named as concept, but of course I will take up the concepts at a very basic level, but then we will stress a little more on the solving, how to draw constructions, how to decide what kind of constructions are to be done, what are the different formulae that we have to use for a particular case, because geometry, as you all know, is a topic which is entirely dependent on the usage of formula, the theorems, the rules, the properties. If you know the formula, you can solve the question. If you do not really know the formula, it would become almost impossible for us to answer the questions. Right? It's not like your arithmetic wherein you can do some kind of guesswork or substitute some simpler value to solve the question. For example, we do this. We put the cost price as 100 rupees, try to find the profit. We do that sometimes, but here such tricks won't work usually, right? So let's get started. So geometry again, it's, as I said, it's a vast topic, consists of several areas, but in this class, we'll be focusing particularly on the problems pertaining to the triangles. Now under triangles, there are some important properties that we have. Let me quickly share that with you. If you take a triangle, ABC, side lengths are small a, small b and small c. So there are some properties that this particular triangle will have. For example, sum of the angles in a triangle, it's always 180 degree. I am sure we all know this. Second property that we have, sides opposite to larger angles are longer. Larger angles are longer. So that means if you see that angle A is greater than angle B is greater than angle C, we don't know the values, but we only know the order that A is greater than B is greater than C, then we may say that the side opposite to angle A, which is small a, side A, will be the longest side greater than B greater than C. So sides opposite to larger angles are longer, right? Now in a triangle, each exterior angle, so the way to find out the exterior angle will be at vertex A, there are two sides which are converging, extend any one of the sides, any one. So the moment you extend the side, you see there is this linear pair which is formed here, these two pair of angles which are forming a straight angle. Out of this linear pair, one is the interior angle and this is what we call it as the exterior angle A. Similarly, we can imagine that exterior angle C here would be this. And similarly, exterior angle B. So there is a property pertaining to exterior angles also. So the property is each exterior angle is equal to sum of interior opposite angles. Next property. Also, if you have in a triangle, if you have sides given to you, we can say that in a triangle, sum of any two sides will be greater than the third side always. If this is not true in any triplet of values, for any triplet of values, then the triangle is not formed. For example, if I ask you, can we form a triangle with these sides? The answer is no, because if you add these two sides, you get 15 and 15 is not greater than 16. For a triangle to be formed, sum of any two sides should be greater than the third side. Just one more thing. As I said, we'll not be stressing too much on the concepts, right? We'll be moving on to the problems. We'll try to discuss the concept and related formulae using the problems. But before that, one more small point. How do we identify what type of triangle do we have? Is it acute angle triangle? Is it obtuse? Is it equilateral? How do we check that? Is if you have three sides like this, say A is less than B is less than C, okay, C is the longest side. Then what we do is, you take square of each side. Take the squares of each side. Add the smaller two squares, a square plus b square in this case. Compare that to c square. If it turns out to be greater, then the triangle that we are talking about is acute. If it turns out to be equal, then the triangle that we are talking about turns out to be right angle triangle. It's Pythagoras theorem, by the way, a square plus b square equal to c square. If it turns out to be less than c square, then it is obtuse. So this is how we identify the type of triangle looking at the side lengths. We shall take up an example also today. Let's get started with the questions one after the other, and we'll discuss more properties there. So the very first problem that we have in today's video is this. You can just pause the screen at this moment. Try out the video yourself, okay? And we'll anyways be discussing as we usually do here. We'll discuss this question. You can just match your answers. So it says in the figure above, there's the figure, PQ is equal to QR. So PQ is equal to QR, is equal to RS further, this RS, is equal to ST, is equal to TU, is equal to UV, is equal to VP. Okay. The angle SPT is approximately how much? Okay. Observe. SPT would mean this angle. Say this angle is theta. Okay. Let's say this angle is theta, we have to find theta. Look at the first point here, PQ is equal to QR. Now consider the triangle PQR. In triangle PQR, if PQ is equal to QR, can I say it turns out to be an isosceles triangle PQR? In an isosceles triangle, angles opposite to equal sides are equal. So if PQ is equal to QR, then the opposite angles will also be equal. That means if this is theta, this is also going to be theta. Okay. Now look at the same triangle PQR. Can I say this is the exterior angle at Q? And we know the property, each exterior angle is equal to sum of interior opposite angles. So this will be equal to theta plus theta, it will become 2 theta. I write 2 theta here. Then consider this, QR is equal to RS. So if you take QR is equal to RS, this triangle here, QRS triangle here, again it's an isosceles triangle because QR is equal to RS. So opposite angles opposite to equal sides will be equal. This is 2 theta. This is also going to be 2 theta. Okay. So this will also be 2 theta here. We may say this. Right. Let me change the ink. Moving on. RS is equal to ST. Consider this. RS is equal to ST would mean this. So that would mean what? This angle here will be equal to the angle here. RS equal to ST. But what is the value? We don't know as of now. Let's try to see if we can find out the value here of this red angle in terms of theta. So how can we do that is, notice, please notice here once. Look at the triangle SRQ. Now in triangle SRQ, please consider the exterior angle at R. How would we get it? You extend one of the sides, either SR or QR. I am extending QR like this. So this angle here entirely is going to be the exterior angle. Right. So exterior angle will be equal to what? Sum of interior opposite angles is going to be 4 theta, this entire thing. But out of that, please notice, these angles are going to be vertically opposite angles, yes or no? This one, dots. So if this is theta, this part here, this small part here is also going to be theta. Theta, this is also going to be theta, vertically opposite angles. And hence can I say, this part here, this one, is going to be 4 theta minus theta, which is nothing, I am cleaning everything, which is going to be 3 theta. Okay, this is going to be 4 theta minus theta. And if this is 3 theta, this is also going to be 3 theta, this entire angle. Alright, then ST is equal to TU is given. Let's try to look at that also. ST is equal to TU would mean these two angles will also be equal. Okay, this one and this one. ST is equal to TU would mean this. Okay. So how can we try to figure that out? Let's try to understand, let's try to see that. So for doing that, please notice one small point, right? Notice the following. ST is equal to TU would mean this angle, whatever it is, alpha if I call it, this entire angle is also going to be alpha. and this can be calculated. This part here is going to be calculated as 180 minus 2 alpha. But let's stop it for now. Let's go further. Let's look at this. Tu is equal to uv. What does that say? Tu is equal to uv means these two sides are equal. So these two angles will also be equal. But still we do not have any value. Let's skip that also. Look at uv is equal to vp. So if you look at uv is equal to vp, now you look at this. If you look at uv is equal to vp, in triangle uvp, it's an isosceles triangle. If this is theta, this part here is also going to be theta. Not just that, please also notice, this angle here is the exterior angle. For the triangle UVP, this is the exterior angle at V. It will be equal to sum of interior opposite angles. So this part here is going to be 2 theta. So this is 2 theta. I'll change the ink once again. So this is going to be 2 theta. This is 2 theta. If this is 2 theta, please consider the triangle UVT, because there Tu is equal to uv is given. If Tu is equal to uv is given, if this is 2 theta, can I say this angle here is also going to be 2 theta? Which further means this entire thing was 3 theta, that means this part here is going to be theta. We may say this is going to be theta. 2 theta and 2 theta. Next, consider the exterior angle at U. How do we do that? We'll have to extend one of the sides. I'll do it like this. So this exterior angle entirely is going to be sum of these two interior opposite angles, 2 theta plus 2 theta, 4 theta it is going to be. But out of that, this is going to be theta. So thus can I say this part here is again going to be 4 theta minus theta, which will get it as 3 theta. This part is going to be 3 theta. Okay, this is going to be 3 theta. Next, ST is equal to TU. If you look at that, ST is equal to TU would mean what? These two angles are also going to be equal. So this entire thing is also going to be 3 theta. This one is going to be 3 theta entirely. Because in this triangle, these two sides are equal. Opposite angles will also be equal, 3 theta. Now if you look at the triangle PST entirely, what are the 3 angles? Theta is one angle. 3 theta is one more angle. 3 theta is one more angle. So this should be equal to 180 degree, sum of angles in a triangle. So that means 7 theta is 180 degree, and hence can I say the value of theta, the value is going to be 180 by 7 degree, which when you simplify is going to be what? 25 5 by 7 degree, right? So this is how we can, and by the way, this is a CAT model question, right? Similar question has appeared in CAT, right, some time back. Right? So I hope you have followed the way in which we have taken up different sets of triangles to get to our answer. So the question was find angle SPT, which is nothing but theta. We get our answer like this. Okay. Let's move on to the next question. Have a look at this again. Please pause the video, try it out. I'll anyways be discussing it here. The question reads, T is an obtuse angle triangle. 2 of its sides are 7 and 13. So T is an obtuse angle triangle, 2 of the sides are 7 and 13. How many possibilities exist for T such that the third side has integral measure? So what would this mean? 2 of the sides are like this. Say this is 7, this is 13, say this is A. Okay. So first let's apply the triangles inequality. What is the triangles inequality? Sum of any 2 sides should be greater than the third side. So can I say sum of these 2 sides, A plus 7, should be greater than 13? So that would mean A value should be greater than 13 minus 7, which is 6. At the same time, can I say sum of any 2 sides should be greater than the third side? So that means A will be less than 20 also. So that means there is a lower limit for A, there is also an upper limit for A. So A should be between 6 to 20, and since A is an integer, possible values for A can be starting from 7 so on till 19. So these are all the possible values, but the point is, all these values will not lead us to obtuse angle triangle. We want obtuse angle triangle. All these might not lead us to obtuse, and thus we cannot say our answer is this. So many different triangles are possible. Right? So how do we check whether a triangle is obtuse or not? We have a condition which we discussed. So if I assume if A is the longest, side, so what should happen? A square, the longest side square, should be greater than sum of the squares of the other two sides, right? So when you simplify, this is 49, this is 169, this is going to be what? 219, 218, right? So A square should be greater than 218. What could be the possible values? A cannot be 11 for example, A cannot be 12 for example, A cannot be 14 for example, A could be 15, because 15 square is 225, it could be 15, yes 15 is also there here. So 15 to any higher value till 19, because I cannot go beyond 19. So thus can I say if A is the longest side, then the possible values of A could be 15, 16, 17. Now since I am saying A is the longest, I cannot take A as 14 also, because it is more than 13, because for 14, 7, 13, 14 will not be an obtuse angle triangle. So these are the 5 possibilities. Next case, if A is not the longest, so that means 13 is the longest. So then what will happen? 13 square should be greater than A square plus 7 square. So that would mean what? A square should be less than 13 square 169 minus 7 square 49. So A square should be less than 120. So what perfect squares will have, integer squares will have values less than 120? Of course A cannot be 11. So A will be less than 11, that means A can be any value starting from 7 till 10. So 7, 8, 9 and 10. These are the possible values, right, where the triangle can be obtuse, right, it will be an obtuse angle triangle, and these are again the possible values where the triangle can be obtuse. So it's asking us how many possibilities exist for the triangle such that the third side has integral measure. So we have 5 possibilities here, right, 15 to 19, and we have 4 possibilities here. So overall there are 9 such triangles. So just to highlight, what are the triangles? The triangles will be like the 2 known sides are 7 and 13, and the third unknown side could be, it could be 7. So 7, 7, 13 type of triangle. It could be 8, it could be 9, it could be 10, it could be 15, it could be 16, it could be 17, it could be 18, it could be 19. All these are same, 13, 13, 13, 7, 7, 7. So there are 9 different triangles as we see here which are possible. I hope we are clear with this. Have a look at this. In triangle ABC, AC is equal to 6 root 5. D is a point on BC and AD is perpendicular to BC. Triangle ABC, AC is equal to 6 root 5. D is a point on BC such that AD is perpendicular. So that means AD is the altitude. If BD is equal to 24, this is 24. And DC is equal to 6, this is 6. Find angle BAC. You have to find angle BAC. Now notice triangle ADC is a right angle triangle. So we have a Pythagoras theorem here. So when you apply Pythagoras theorem, we have AC square should be equal to AD square plus DC square. So that means AD square will be equal to AC square, which is 6 root 5 square, minus DC square, which is 6 square. So when you simplify this, this is nothing but 5 into 6 square minus this is 6 square. So 5 into 6 square minus 6 square will make it 4 into 6 square, which can be calculated. Let's calculate this also. 36 into 4 is 144. So thus AD can be calculated as square root of 144, which is 12. So we get this length as 12. So this length happens to be 12. Now we have a property, all right. We can make use of a property here. The property is, if you notice, from the vertex A we are dropping a perpendicular. So the product of this particular, the value of this particular perpendicular happens to be 12. So we have a property that, notice, if square of this perpendicular is considered and product of the segments which are formed on this side BC is considered, if they turn out to be equal, if they turn out to be equal, then the triangle will be said to be a right angle triangle. That's the property that we have in right angle triangle. So in a right angle triangle, if you drop a perpendicular here, then square of this perpendicular will be equal to product of this two segments P into Y. So if that happens only in right angle triangle. And if you notice here, 12 square 144, 24 into 6 also 144. Thus can I say this angle A here must be a right angle. It should be a 90 degree. Right? Or another way of getting to the answer could be, right? This one way, it's a 90 degree. So he's asking us angle BAC, it's 90 degree. That's the answer. So another way of going about answering this could be, so once you get 24 and 12, you can find out AB also. We may find out AB too. So what will be AB? AB will be, once again by applying Pythagoras theorem, 24 square plus 12 square, square root. AB is going to be this. So it's going to be what? 576 plus 144 is going to be 620, 720 square root. And by the way, when you look at 720, one second, we can simplify this further. We could write it as 12 into root 5. So this length is 12 root 5. Now you can apply cosine rule here. Let's call this as theta. So the cosine rule if we apply, so the cosine rule works like cos theta is equal to sum of the squares of the adjacent sides minus square of the opposite side by 2 times product of the adjacent sides. So just to help you recall the cosine rule will be like, if this is side A, this is B, this is C, this angle A. So cos A is going to be equal to sum of the squares of adjacent sides, B square plus C square minus square of the opposite side, A square by 2BC. This is how we apply the cosine rule. So here when you simplify this, this is 720 plus this is 180 minus 900 by something. So if you look at the numerator here, this turns out to be 0. And when is cos theta 0? Only when theta is 90. In case of a triangle, only when theta is 90. Hence again we can say that this missing angle theta will be 90. So this is one way wherein we know the property of right angle triangle. That is the other way wherein it's a slightly longer way, but there's one more way by using the cosine rule. Right? There could be other ways also. Of course, geometry problem can be solved in more than one way, so right. But I would suggest you all to think of other ways for this question, right? If there is any. So let me just clean this. So with that, we have come to the end of the video today. So I'll come back with more videos on geometry, right? Because the triangle itself will require more discussion, right? Similarity of triangles is there, properties on medians are there, etc. Right? We'll have subsequent videos. We'll discuss all of that also. And in the meantime, if you have any special suggestion, right, a request that you have to make, right, regarding what areas are to be covered, particular areas, you may also write that in the comment. We shall definitely consider that comment and include those topics in our subsequent videos. So on that note, let me end the session here. Thank you and all the very best.